So as you know, we adopted a new textbook this year, and there's a lot of mistakes on the resources they gave us. Like number 19 on the worksheet, it says k to the 0 times k to the 4th times k to the 6th. That's what the worksheet says. But if you flip it over to the backside where the solutions are at, it makes it look like a -6, right? So on the original worksheet, it's a +6. So if you actually did the math correctly, k to the 0 is just 1. So you have a 1 times k to the 4th times k to the 6th. And you know that rule 1 says you add exponents. So it's really just a 1 times k to the 10th if you add the exponents. So your answer should be k to the 10th. However, that's not the answer in the back, because in the back, they have it as a k to the -6. So there's a blue negative sign right in front of that 6. So if it depends on how you're doing it, let me erase my work here. And let me go back and do it with the way they have the answer, okay? So this way we got k to the 10th. But if we actually look at it as a k to the -6 up here, then the k to the 0 cancels out, it's 1. So you really have k to the 4th, and the k to the -6, you would grab it and move it to the other side. So you'd have a k to the 6 down here, right? Right?
Yeah, right.
Okay, so then you could cancel out 4 k's with 4 of these 6, and you'll have 2 left over. So your final answer would be 1 over k squared. So I guess it depends which side of the worksheet you're doing. If you were doing it the way it was originally with the +6, your answer should be k to the 10th. But if you actually look at your answers, they mark this 6 as a -6, which causes it to go down to the denominator, and then you could cancel and you get a final answer of 1 over k squared. So this is your homework. Some of it is super easy, like number 22. What's the answer? 1. There's no need to even think about it, because the whole thing, it's in parentheses, and it has a power of 0 on the outside, and we know that anything to the power of 0 equals 1. So it would be kind of ridiculous to go to the inside of this thing and start canceling out the 2 with the 16, get an 8, cancel out the p to the 3rd with the p to the 5, get a p to the 2nd, w squared with these cancels, you get a 1 left over. What's the point of doing all that if you already know that the outside exponent is a 0, which causes the whole thing to become a 1? So some of these are super easy. It's just a question of moving things around. Is there anyone that you just think, oh, that one looks hard, I want to see that explained? Anyone you would like explained? 24? Sure, why not? 24. 24 involves a couple of rules. One rule is moving the negative exponent terms to the other side. The other one's canceling out. So the 5 over 15, or the 15 over 5, you could reduce that by 5, and you'll have 3 left over up on top, and only a 1 left over on the bottom, which means nothing on the bottom. But then you go to your x's, and you really have 6 x's up on top and 1 x on the bottom. So one of those x's cancels out with one of those, and you're going to have 5 left over up on top. And then you get to the y's, and you have negative exponents on the y's, so grab that guy and move it down, but grab this guy and move it up. So your final answer, you're going to have a 3 up on top, a 1 on the bottom, a x to the 5th up on top, a y to the 11th up on top, and a y to the 9th on the bottom. Now, I said final answer. I shouldn't have said that, because there's still one more thing to do. What else do I do? What else could I do? Cancel. Cancel the y's. So I have 9 y's on the bottom. All of these 9 y's are going to completely cancel out with 9 of these 11. So I'm going to have 2 of them left over up on top. So my final answer is 3x to the 5th, y to the 2nd. You could put over 1, but that's kind of unnecessary, because whenever you have just divided by 1, it's that same exact answer. So there's my answer. Let me actually jump to number 16. There's something pretty cool about 16. There's like a second option. Like number 16, you could distribute the outside exponent of -2 to to the 5 and to the 3. So you'd end up with 5 to the negative 2 over 3 to the negative 2. Now, yes, you have both exponents being negative, so you'd have to get this guy and move it down. You have to get this guy and move it up. So your final answer should be 3 squared over 5 squared, which means that your final answer is what? 9 over 25. Now, there's another option. You don't have to do it this way, but it's just an option I want to tell you about. Whenever you have a fraction to a negative power, yes, you could distribute in, that's perfectly fine. But another option is to change the negative exponent to a positive and flipping the fraction. So you could change this to a 3/5 and make that a positive 2. And then you'll just jump straight to this answer over here, 9 over 25, when you distribute. So it's just another option, and I just wanted to explain that to you guys. So if you want to do that, you could do that. So you could go the original route, distributing to each and every term, and then moving, or you could take that negative exponent and flip the inside fraction, changing it to positive, and then distributing. It's up to you.